Hello guys, welcome to KSV Electrics. Guys, today we are going to learn how to draw the vector diagram of an alternator when it is under the lagging load. So guys, please do watch the video till the end so that you can know the conclusions we are going to conclude from the our vector diagram. So now I don't know what is the equation, or I don't know how to draw the vector. So for the beginner this video will be very useful. Okay, see, I know only one equation, that is this is a generator, right? Synchronous generator. So E is equal to V plus IA ZS. Okay, this is the only equation I know. This is a AC, right? So I am using the impedance ZS. This is a synchronous impedance. Now I'll be writing V plus IA into RA plus what I'm going to write here, J XS. Okay, from this V plus IA into RA plus XS. So XS is the combination of leakage reactance plus armature reactance. So from this I'll be writing J IA into XL plus J IA into XA. Okay, this is the voltage of an alternator under no load condition. Okay, so from this we'll be drawing the phasor diagram. This is the armature reactance. I know only this. From this basic equation we'll be drawing the vector diagram. See, just listen. So first I am taking the voltage vector. This is the voltage vector V. Okay, so definitely the current will lag the voltage. Okay, this is not the resistive load, right? It is here we are having XA, XL, and okay, so that definitely the current will lag the voltage. But see, this is not exactly the 90 degrees. There will be just a small angle that will be I'm indicating as pi. Okay, now this is the V, so I'm extending this V to get very clear diagram. Okay, this is here. Now done with V. Now definitely this IARA will be in phase with IA, right? So this IARA will be in phase with IA. Now this is 90, right? This is exactly 90 degrees with this. So this is our IAXL, and similarly this will be in phase with this IAXL. So I am further extending this. This is the whole thing. This is IAXS. Okay, now I am joining this. This is our E vector. Okay, and up to this is IAXL. okay, leakage reactance. So if I join these two, this will be our air gap voltage. This is ER. I am indicating with it ER. Okay, I got E. This is the V. Okay, this is IARA, IAXL, okay, IAXA, and the whole thing is IAXS. So I have drawn the diagram now. Now I am indicating the angles here between V and IA. This is pi. So between V and IA, this is pi. Okay, next between E and V, between E and V, this is delta. Between E and V, this is load angle delta. Okay. Now between E and I, this is a complete angle. I am indicating it as psi. Psi is between E and IA. Okay. So this is a internal power factor angle, and delta is our load angle, and psi is load power factor angle. Okay, have concluded now. See, one more thing. Along IA there will be armature flux, right? Along IA there will be armature flux. Okay, so if there will be armature flux, we'll be having definitely armature MMF. Okay, this is the armature MMF. Next, see, the main field MMF will make exactly 90 degrees to our generated voltage E. So exactly 90 degrees I'll be drawing our main field MMF. Okay, so our main field MMF will be in exactly 90 degrees to E. So this is the armature MMF, this is the main field MMF. The resultant will be somewhere here. Okay, this is resultant pi r or MMF r. This is the resultant MMF. Okay, I'll be joining in dotted form. So I have shown you pi r, that is this is the main field flux pi m. Okay, now I want to know the angle between main field MMF, armature MMF. I want to calculate from the phasor diagram. So at the end I will be giving you some conclusions. Okay, concentrate very careful here. See, now what is this length? IARA. Okay, this length is IARA. Okay, see, this length is IARA. Okay, this angle is phi. So this is facing here, facing towards this side. What will be this? Definitely it is a V vector. This will be the hypotenuse, and this should be V cos pi. Okay, this whole length will be V cos pi and IARA. Okay, V cos pi IARA. Next, now what will be this length then? V sin phi, right? In this triangle, this is the V, this is the V cos phi, IARA. Definitely this opposite side, this will be V sin phi. Okay, V sin phi. If I want to write the total E, okay, see, if I want to write the total E vector, okay, how I can write? See, just concentrate here. If I want to write, so E is equal to, okay, I want to write the total equation. E is equal to V cos phi plus IARA V sin phi plus J IAxis. Okay, V cos phi plus IARA V sin phi plus J IAxis. Okay, this is how we write E. How to find ER? ER is equal to V cos pi IARA and So E is equal to, we can write this way, or else I can go by this way, V, this and this. Okay, so V plus IARA plus J IAXL. Okay, J IAXL. This is how we find the air gap. Okay, air gap voltage ER. Now very important thing is conclusions. Now if I ask you what is the angle between main field MMF and armature field MMF, so I'm asking the angle between main field MMF and armature field MMF. This is the angle I asked. So just see the diagram. Up to here 90 degrees. Okay, up to E it is 90 degrees. From main field to this is the E. From here to here pi. So the angle between main field MMF and armature field MMF will be 90 plus psi. Okay, now here air gap field is present, so there will be some angle between ER and E. Okay, there will be some angle between ER and E. So if I ask you one more thing, that is, if I gave you power factor angle, okay, if I gave you power factor angle, this is an important model, I'm giving you just an example. See, if I gave you power factor angle and if I gave you angle between E and V, okay, if I gave you power factor angle and if I gave you angle between E and V, then I will, if I ask you what is the angle between main field MMF and armature field MMF, so we know that definitely the angle is 90 plus psi. So psi definitely in the lagging it's a sum of both, right? See, psi is equal to pi plus delta. So I'll be adding both the angles and that will be added to here. So this is how we can make the questions based on this diagram. Okay, now see, similarly if I gave you the angle between main field MMF and armature field MMF, see, if I gave you the angle between main field MMF and armature field MMF, I'm giving you directly this. So now I have given you main field MMF and armature field MMF angle. Okay, I have given you main field MMF and armature field MMF angle, and I have given you power factor angle. Okay, I have given you internal power factor, load power factor angle. That means this is delta. I have given you this and this, and I asked you to find load power factor angle. Sorry, I have given you load power factor angle, this is pi, and I asked you to find load power factor angle. So I asked you to find the load power factor angle pi. So we can make the question. See, this is nothing but 90 plus psi. Okay, psi is equal to pi plus delta. Okay, total angle is given. From this I will be getting psi. From this I know already pi. From that I can be finding the delta. So this is how we'll be drawing the vector diagram, and this is how we will be calculating the angles. Okay, in the next video we'll be drawing for leading power factor. So guys, please subscribe to our channel, okay, and click on the bell icon. Thank you.